फ्रेंड ऐश्वर्य पढ़ाता हूँ आपको गेट ईएससी के लिए। फ्रेंड्स, आई हैव डन माई एमटेक इस्लामिया 4 times. I have qualified GATE with my best AIR 226. I do have 7 years of teaching experience and 2 years of industrial experience, and all these are the subjects which I am basically taking on Unacademy classes as well as on Unacademy Plus. The subjects are theory of structure, RCC, geotechnical engineering, and strength of material. And my dear friend, let me come over this GATE and ESC. Actually this code is an universal code at GATE ESC के लिए आपको पढ़ा रहा हूँ, तो आप लोगों को बस ये कोड GATE ESC में प्रमोट करना है. You can promote this code at various other competitive field like SSC JE, engineering services, okay, civil services, IIT JE. In all the segments this code is applicable, my dear friend. Am I audible to all my dear friends? Okay. The video is okay or not? Okay, so it is going all right. Yes. Okay. Yeah, it is going live. So let's proceed further and see what all are the benefits of as an Academy iconic subscription. Okay, so let's see that. I hope my background video noise is not there. Okay, so engineering and strength of material. Okay, so why do we need Unacademy Plus? This is a question. So at Unacademy Plus, you can avail the facilities of daily live classes, crash courses, weekly tests, doubt solving sessions. It is going to conduct in both the languages, English as well as in Hindi, and rank improvement batches are also there. But if you simply want to upgrade your plus experience into an, my dear friend, you may opt for our iconic subscription. And in iconic subscription, I would say that we are going to assign you a personal coach, or you can say your local guardian, who is going to plan the study booster sessions for you to analyze your test at the personalized level. Not only this, you will also be getting the specialized notes and practice sets on the daily basis. So all these are the upcomings of iconic plan over the plus subscription. Okay, so whether you have to go for plus or iconic, so my code S10 is always readily available. Okay, my dear friend, now see what all are the various upcoming batches by us. So we have launched the Evolve batch 2. It is a fourth batch, okay, which we have launched on. And if you are targeting for gate 2023, then in that case our Ascent batch is going to help you a lot. So you can see that all these batches have been initiated by our top educators. So here also S10 is going to, and if you want to crack ESC, and then you might be knowing that this journal study thing is going to play a very vital role in your success, because this is the thing which is actually making the difference, okay, from the technical and non-technical guys. So for them we are having target ESC prelims for gate 2021, and here as well my code S10 is readily available. Okay, so it is batch B. So first one has been started in the month of January, and this second batch we are starting in the month of February. Okay, so now my dear friend, if by chance you haven't downloaded our app, so you can download it from your Play Store or App Store, and you can use this invite code as well. Okay, Ashton, you can also use this invite code as well, so that you can unlock our special classes, quizzes, live test series, and Unacademy combat. So let's start the session, my dear friend. So welcome to gate 2021 analysis on structural analysis. So you might be knowing that 6th of Feb को we had our gate exam, तो इसके अंदर इस बार structures का काफ़ी weightage रहा. So I thought कि one by one I'm going to share the questions asked in gate 2021 by my subject. So I'm going to take structures, then I will take RCC, and after that I will be taking geotechnical engineering, and mechanics as well. Okay, so all these structures I'm going to you can say take. Is it okay? So here are these few questions based on both the sets. So here is question number one, and this question was, so let me write here, morning set. Morning set was 9:30 to 12:31. So okay, this is all. So you have to find the magnitude of the horizontal displacement of joint, you can say G. So please tell me what is going to be there. So are you guys attempting the question? A truss EFGH is shown in the figure in which all the members have same axial rigidity. Okay. So in the figure, P is the magnitude of external horizontal forces acting at the joint F and G. If R is going to be 5 Newton and P is 150 kilonewton and the length of each vertical and horizontal member is 3 meter, then my dear friend, you have to find the horizontal displacement of joint G. Okay, so think over it. So maybe you are treating this problem as you can say trust problem, but what when I solved it first, so I identified that this is going to be a simple one bar problem in which the bar FG is going to elongate, and you simply have to tell what is going to be the elongation in that bar, isn't it? So although now we don't know whether it is a bar or not, so we have to solve it by using our normal procedure, and I would like to recommend procedure for this would be unit load method. So what we are doing in unit load method, so in unit load method, if we want to find the, you can say, delta, then it is pi ki Li upon AIEI. Okay. So here Pi is the forces in each and every member due to given load system, and you can see here that the given load system is P, F and G are being loaded in the horizontal direction. So after that, in question they ask that they need to find deflection at point G. So as per the limit load unit load method, we have to remove all the external loadings. After that, we have to apply a unit load at a location where we actually need to calculate deflection. So after removal of this load P, I have to apply a unit load at G, and then again I have to calculate the forces in all the members on the given truss. So once I'm doing that, so I would be getting K system of forces. Earlier I had a P system of forces. So now after superimposing them, I would be able to get the fraction PKL upon AE. And as I told you that this is simply going to be bar problem only. So other than FG members, all other members are zero force member. So you do not have to calculate the forces due to unit load as well in each of the members. Okay, so you'll see how we are going to tackle it. Okay. Okay, so let me find the reaction first. Let me find the reaction first. So this is the vertical reaction at E, this is the vertical reaction at H, this is the horizontal reaction at E. Because E is the hinge support, it may have two maximum possible reaction. So reaction would be HE, reaction would be HE RE, and this is RH. Okay, RE and RH. if you are doing the summation of fx is equal to 0, then it is equal to he plus p minus p is equal to 0. So no horizontal reaction is here, no horizontal reaction is here. And if you are going to apply the summation of fy is equal to 0 here, then as well you can see summation is also equal to 0, because but it doesn't mean that re and rh both independently are going to be equal to 0, because it may happen one may be 2 and another may be minus 2. Their sum is 0, so it doesn't mean that independently they are going to be equal to 0. So in order to calculate re and rh, we can use our third equilibrium tool, which is known as the summation of mz is equal to 0, means the sum of moment about a point is equal to 0. So let me calculate this summation of moment about point number E, and if I am going to do that, then what can I do here? See, so summation of mz is equal to 0 if I am doing, then minus, what was the case there? Minus RH into L, minus RH into L, okay, plus P into L minus P into L is equal to 0. So RH is going to be equal to 0. RH is going to be equal to 0, and similarly now you can say if RH is 0 and their summation is also 0, if A plus B is equal to 0, if B is 0, then A is also equal to 0, isn't it? So here is also your 0 only, isn't it? So now we have seen that what are the possible you can say reaction. Okay. Okay, that's all. So let me redraw this frame after putting the original value of HE, RE and RH. As you can see that originally neither HE is there nor RE is there, and RH is also equal to 0. So if I am redrawing this truss, after putting these values, if I am redrawing this truss after putting this value, then it may look like this. Okay, so this is a horizontal member, this one is vertical member, base member, vertical member and diagonal element. Nomenclature here you can see as E, F, G, H. This is E, this is F, this is G and this is H. Okay, so no reaction is there, and P and P are acting here. So this is P with red I am showing, this is also P. Okay, so here you would be having a P tensile. Tensile I will denote by positive sign, and compressive I am going to take negative sign, or vice versa you can also do. So this is going to be 0 now. Why it is 0? Because this E is a joint which is having two members and no external load or reaction is acting at joint E. So if both of these members are non-collinear member, in the absence of any external load or reaction at a given joint, I can say that both of these members are going to be 0 force. And if you are not having faith on my statement, then simply apply summation of fx is equal to 0 and summation of fy is equal to 0 at joint number E. If you are going to do so, then summation of fx 0 is simply telling you the force in the member EH is equal to 0. Okay, and if you are doing the summation of fy is equal to 0, then it means f in member EF is also equals to 0. Okay, so simply you guys can remove these two forces, these two members. Once these two members have been removed, then we can switch on to joint number H. So in joint number H as well, if I am going to see, these two members are present and both of these members again are non-collinear members. If they are non-collinear members, then they both has to be equal to 0 until and unless any external force I am going to apply here. Is it clear to all my dear friends? Tell me if you guys are having any doubt so far. Tell me if you have any doubt so far. Okay. Okay, so no doubt. Okay, I am having some lag on my phone, so okay, I'm making it crystal clear. So this is 0, this is 0. So eventually we came to know that the force in the member Fg is tensile P. Okay, so force in the member Fg is tensile P. So as I told you earlier that tension I'm going to show with positive sign, and compression I'm going to show with negative sign. So next thing you can see here, it's a time to apply unit load in my system and remove all other given loading. So if I am applying the unit load system, so it would be there 1 unit, and rest of the structure has to be same. We cannot alter the structure. The only alteration which we have to made, removal of external load and application of unit load. And where we have to apply unit load, we have to apply unit load in that direction where we need our deflection. Since I needed deflection in this question in the horizontal direction at G, so that is the reason why I applied the horizontal unit load at G. Okay, so EFGH is the thing here. This is E, this is F, this is G, and this is H. So if this is 1, then if you are making the horizontal forces equation, then it will also be equal to 1. So I may write here 1. And if you want to calculate the value of H, RH due to unit load, then take moment of the system about E. But let me tell you one thing, this much hard work is not at all required. As I told you, by doing the unit load method, eventually you have to perform Pi, Ki, Li upon Ai, Ei. Since Pi is 0 in every other member than Fg, so it's better you put your entire focus in the calculation, for the calculation of force in the member Fg due to unit load. So maybe yes, if you need forces in the whole member, then you have to do this much work. RH into L, 1 into L is equal to 0. So RH is going to be 1 by L, and R is going to be minus 1 by L or downward 1 by L. But right now, since I know that all other member forces are 0, so due to that you are going to say this is also equal to 1. So 1 tension, you can say it is equal to 1 tension. 1 tension. So I'm not saying that remaining are 0. Okay, don't think remaining are 0. I'm saying when you are going to multiply these forces with 0 of the real member, that in that case they are going to lose their significance. So better not to waste our time here. So it's quite better that we are not wasting our time here. So now the delta you can see. Now the delta you can see. Delta is equal to Pi Ki Li upon Li. So Pi I am only considering from you can say Fg member. So it is simply Fg K of Fg upon Ae of Fg, and here the Ae has directly be given as R for all the members. Okay, so if this is the case, then Pfg is how much? KFG is how much? It is plus. It is LFG is how much? It is going to be how much? It is going to be 1, or it is given in the question. Okay, let me put L only. Upon what is AE? A is given as the axial rigidity, also your R. So let me put here R. Okay, so this is the solution. This is the complete to simply keep the values of P, L and R in order to get the final result. So delta is going to be equal to what is P? P is 150 kilonewton. So try to write the things with units so that you guys are not going to make any mistake until and unless your expression is empirical. Okay, it's my advice, always try to go for unit wise. So 150 kilonewton means 150,000 newton. Okay, after that what is the value of L? So I would like to calculate this expression in millimeter. So in millimeter I have to keep length in millimeter. So 3 meter is equivalent to 3000 millimeter. It is 3000 millimeter divided by 1 is always there. Okay, and r is also in kilonewton, but the value of r is given as 500,000. Okay, the value of r is 500,000. Okay, is it clear? 500,000 newton. So only calculation part is there, my dear friend, you can tackle it. So 500, this is 2 will come, this is 30. So 300 into 3. Okay, 300 into 3. So A value is how much? Let me recheck that. 500 into 10 ki power 3. So 500 into 10 ki power 3. So 10 ki power 3 will not more come. So that is the correct answer. So the horizontal deflection of a joint G is going to be equal to 0.9. You can say mm. 0.9 mm. Is it clear? Nikhil Chavda is asking, sir, whether we will be able to. Okay, my dear friend, let me tell you one thing, that my mobile connectivity is not very good today. So actually, I'm not at my normal studio, so I am outside. So my mobile is not connected with the good internet. So I will not be able to read all of your comments. So right now I have seen the current comment from Nikhil. Sir, whether we will be able to get 50 NIT at 50 marks. Yes, you can get NIT in at 50 marks. Yes, Nikhil, you will be getting it. Okay. Okay. But the question comes, which NIT do you need? Okay, so there you might have to compromise, but you will be able to get NIT at 50 marks. Okay, it is a okay score. Average score, I would say, not very good and not very bad. Okay, but next time if you are preparing for gate, then Nikhil, try to convert these 50s into 80s. Okay, in order to get good IITs or placement in the good companies, PSUs. Okay. Okay, dear. So this was the first question from the morning shift, and let me take one more question. Okay, so we have to refer the truss here, and we have to determine the compressive stress in kilonewton per mm square. Okay, in kilonewton per mm square we have to find the compressive stress, or I'm not sure about the units, because uh, all these be kilonewton per meter square or newton per mm square. I can't not taking guarantee of this data, but that is sure, whatever they are asked, that is quite clear. They want compressive stress in top member, even if it is data is varied. So still, my dear friend, I would say that you will be able to get the correct concept. Okay, so actually this I can help you. It is PQRST. It is PQRST, and the load is coming in kilonewton. Okay, so due to this 10 root 3 kilonewton, I would say that reactions would be equal. Reactions would be equal, and no horizontal reaction would be there. So 5 root 3 and 5 root 3 would be there. both are in kilonewton. And if you want to calculate the compressive stress in the member QR, then first of all we have to calculate how much is going to be the horizontal forces are nothing. It is simply equal to force upon area, or more accurately if I have to say, it is equal to internal forces divided by area. So what are going to be the internal forces? First of all we have to see that. So I need the internal force only in the member QR. I need the internal force only in the member QR. So in that case what can I do? I can go for method of section, because of calculating stresses only in one member or two member, and we are not in a mood to solve entire stress, then directly we can use the method of section. So in method of section what can I do? I can actually cut this section in this fashion so that we can split it into two parts. Okay, and after this what I can do, I can take the moment of right hand system about T, because total unknown forces would be three: force in the member QR, force in the member TQ, as well as force in the member TP. But out of these three forces, these two forces would be eliminated, so only one force would be left over. So force in the member QR multiplied by this you can say height, okay, is equal to minus 5 root 3 into this height. So one information was also mentioned in the question, that all of these members were having similar length, that is equal to L. And my dear friend, if all of these members are going to have length is equal to L, then it is an equilateral triangle, and we all know in an equilateral triangle each angle is 60 degree. So if each angle is 60 degree, in that case what we can do? So this is if this is L, then what about this? Anybody? It is L root 3 by 2. It is a L sine 60, and sine 60 is root 3 by 2. Okay. So now let me redraw this cutted portion. So right hand portion I am only going to draw. So this is one member. This is like this. Okay. So TQ and TP are there. So So this is unknown force. So by default, all the unknown forces I am going to take it tensile. It is TQ. It is TP. Okay. So the nomenclature of the nodes are RTS, RTS. So this time let me take the moment of this system about point T. In that case I can write 5 root 3 into L, because TS member is also having length L, plus FQR. What is the perpendicular distance from R to T? This is the shortest distance. Now force into lever arm is going to be equal to your moment. So it is going to be L root 3 over 2 is equal to 0. So by doing this equation you would be getting root 3 would be cancelled, and FQR is equal to minus 10. Minus is simply saying that the assumed direction of the force is incorrect. Magnitude wise no issue. So we have assumed force in the member QR to be tensile, but the final answer is coming negative. It means in reality force in the member QR would have been compression 10. Okay, so that's all. So force in the member QR is clearer here. So if FQR is there, 10 kilonewton, and compression, Okay. So what about compressive stress? So compressive stress sigma is simply force upon area. So obviously compressive stress has to be compressive because the forces are compression. So 10 into 10 to the power 3 Newton over, what about area? Area is 10 to the power 4. But area is not area. See, this area is 2 area. Okay, mm 2. So answer is 0.5 Newton per mm square. And if you need answer in kilonewton per meter square, then 0.5 kilonewton over 1000 into meter square into 1000 into 1000. So this is, hello Rabjeet, कैसे हो?